Okay, here's how to solve this problem in Desmos. F of x is this red graph right here, the square root of 6x. G of x is this blue graph, the parabola, y equals x squared. And in order to set up a definite integral to find the volume of revolution involving this region between those two curves about the x-axis, you need to know this point of intersection, which we can solve here by the substitution method. These are both equal to y, so they have to equal each other. It's a radical equation, square both sides. One of the solutions is the cube root of 6, which is this value right here. And so this is the point cube root of 6 times f of the cube root of 6. Those are decimal approximations. So to revolve this region about the x-axis, it's your choice whether to use the washer method or the shell method. If you're going to use the shell method, you're going to have to find the length of this typical shell right here. So you're going to have to solve these functions for x in terms of y, which I've done down here, but that's probably a little bit harder. So to use the washer method, we're going to take pi times the integral from 0 to a. So these typical washers are piling up along the interval from 0 to the cube root of 6. And then it's the outer radius squared minus the inner radius squared. And f of x, the distance from the axis of revolution to the outermost portion of your washer, is f of x, and the inner radius is the distance from the axis of revolution to g of x, or x squared. And if we take that distance minus this distance, we've got the height of the shell, which is that distance right here. Okay, and then so rounding to 4 decimal places, 18.67 200 looks like. Okay, there you go. Hope that helped. If you have any questions, post a comment.